Hello everyone. The question says that which of the following examples represent periodic motion? So we have to find out among these four options what are the periodic motion and what are not the periodic motion. So in the first option we have a swimmer completing one return trip from one bank of a river to the other bank. Now in this case the swimmer is completing the trip from one bank to one bank, completing a return trip from one bank to other. So this is not a cyclic motion because the swimmer is just completing one round, and it is not stated that whether it will go or not. And also if it goes on repetition, then we don't know about the speed of the swimmer, that does it take equal amount of time in returning back each and every cycle or not, because in periodic motion the motion should repeat, and also it should repeat at a regular interval of time. Then only we can say that it is a periodic motion. Now in the second case we have a freely suspended bar magnet displaced from its north-south direction and released. Now since the magnet is freely suspended, so we can say that once the bar magnet is displaced from its original position, then the Earth's magnetic field will cause the restoring force to act on it, and since it is freely suspended, the magnet will experience little to no resistance from air. So we can say that the motion of the magnet will be periodic in this case. Now in third case we have a hydrogen molecule rotating around its center of mass. Now we can say that this is a periodic motion because the rotation of a molecule is periodic because it completes one full rotation and then continues to rotate in repeated cycle. Now in fourth option we have an arrow released from a bow. Now in this case we can't say that it is a periodic motion because neither it is cyclic nor we know about its the time duration of its cycle, because it is not cyclic at all, so it is not a periodic motion. Thank you. The question says that which of the following example represent nearly simple harmonic motion and which represent periodic but not simple harmonic motion. So we have to distinguish between periodic motion and simple harmonic motion, and we have also and it's also stated that which is periodic but not simple harmonic. So there are four options, and in the first option we have a rotation of Earth about its axis. So we should first clear out the definitions of periodic motion and simple harmonic motion. So a periodic motion is a motion which repeats itself, like we saw in the previous example, and it also repeats at regular interval of time. But in case of simple harmonic motion is a type of periodic motion where there is a restoring force in the simple harmonic motion which is directly proportional to the displacement. So we can say that here acceleration or mass times acceleration or force is directly proportional to negative of displacement. So it means that when the object is moving in this direction, then an attractive force or restoring force is acting in the opposite direction of this motion. So and it is also periodic because it repeats at regular interval of time. So a periodic motion is a simple harmonic motion if it is acted upon by force which is in the negative direction of its motion. So let's start differentiating between these two. The first is rotation of the Earth about its axis. Clearly this is not a simple harmonic motion because the rotation of Earth does not involve a restoring force that is proportional to the displacement. So it is not a simple harmonic motion, but it is a uniform circular motion. So we can say that since the day and night days interval or the days interval are same, that is 24 hours, so we can say that it is a periodic motion but not a simple harmonic motion. Now in second case we have motion of an oscillating mercury column in a U-tube. So in an U-tube let us assume that this is mercury, and if we by the action of pressure or some other way, if we unbalance this level, then there is a restoring force that develops due to the acceleration due to gravity or gravity. So we can say that this is a simple harmonic motion, and this restoring force will be proportional to the motion, the direction of motion. So we can say that this is a simple harmonic motion. And in the third case, we have motion of a ball bearing inside the smooth curved ball when released from the point slightly and above the lowermost point. So it's like this, the ball bearing. So it is written ball bearing because ball bearing is really smooth, they have really smooth surface. So the question is trying to imply that we should neglect friction in this ball bearing, and the ball is also plane. So once we release this, a conservative force, that is the force of gravity, is acting. So we can say that the motion will be simple harmonic in this case, because when we release this ball over here, then it will gain kinetic energy and it will rise on the other side. And since when it will rise on the other side, then the retarding force will be acting, that is in opposite direction of its motion. Since it is going up, the force will be acting downwards, so it will resist the ball bearing, and that's what the condition of SHM says. So this motion is going to be a simple harmonic motion. Now in fourth question, we have general vibration of polyatomic molecule about its equilibrium position. So the motion of molecule about its equilibrium position is very complex, and it is not simple harmonic motion. So neither it is a periodic motion. It is a periodic motion but not a simple harmonic motion. So we can say that option B and C exhibit simple harmonic motion in this case, and A and D exhibits periodic motion. Thank you. The question says that below figure depicts 4 xt plots for linear motion of a particle. Which of the plots represent periodic motion and what is the period of motion? So here there are two questions. First we have to figure out the periodic motion among these 4 plots, and if it is a periodic motion, we have to figure out the period of motion, or the time period, or the time duration at which they repeat itself. Now we know that the periodic motion is repetitive in nature, that is, it moves from one point to other point at regular interval of time. So there are cycles, and the cycle is repeating, and the cycle is repeating at regular interval of time. So in order to figure out from the plot, we should look for the repeating plots. So let us visually inspect all these 4 plots now. So in plot 1, we see that with the time scale, this x position of the particle is moving in one direction and it is not repeating, so it can't be a periodic motion. Now in second plot, we see that the plot is repeating indeed, because let us start inspecting at time t equals to 0 seconds. So it is at certain point in the x direction. Now it increased and it again decreased, and it went to the minimum point, and then again it started increasing, and it again same maxima that it was before. So we can say that this pattern is repeating itself at number of times. So this is a repeating cycle, and also the time interval is also looks like it is repeating at regular time interval, and it is approximately of 2 seconds. Time period can be found out by measuring the time duration between each 2 maximas or 2 minimas. So let us assume this to be the maxima. So the duration between these 2 points would be the time period. Now let us inspect plot C. In this plot, we see that the motion is very irregular. It is not repeating because the maxima attained is increasing and decreasing randomly. So we can't say that this plot represents a periodic motion at all. And in plot D, it is a sinusoidal plot in which we can see that a maxima attained is same in all the cycles that has been given over here, and a minima attained is also the same. So we can say that this is a cycle, and it is repeating indeed at regular interval of time, because we can see that the time duration between 2 minimas and all these minimas is same, approximately same, and all those 2 maxima is also same. So again we see that upon visual inspection we can see that the time period is approximately of 2 seconds over here. So in both these plots B and C, the time period is of 2 seconds and it is repeating. So it can be called a periodic motion with a time period of 2 seconds. Thank you. The question here says that which of the following function of time represents simple harmonic motion, periodic but not simple harmonic motion, and non-periodic motion. So we also need to give the period for each case of periodic motion. Here omega is a positive constant. So we know by definition that any simple harmonic motion can be written in the form of a cos omega t plus minus phi, where phi is the phase angle, initial phase angle, and or in the form of a sin omega t plus minus phi, where again phi is the initial phase angle. Now here whatever comes in the coefficient of variable t or time is termed as omega or the angular frequency, and we know that by equating this coefficient or the angular frequency by 2 pi by t, where t is the time period, we can find out the time period of the simple harmonic motion. So let us go with the options. So in the option 1 we have sin omega t minus cos omega t. Here using an identity, if we can transform this in the form of either a sin omega t or a cos omega t, then we can say that it is a simple harmonic motion. Else we can see that this is a periodic motion, because this is just addition of two periodic motions. So let us investigate it further. So we can use identity over here, and identity we can use over here is sin a minus sin b, and that is equals to 2 sin a minus b by 2 cos a plus b by 2. And using this identity we can write that equation in the form of root 2 sin omega t minus pi by 4. So we can see that this equation is in the form of a sin omega t minus phi, where a is root 2 or the amplitude is root 2, and here omega is omega, just so we can find out the time period using this formula. So time period would simply be equal to t equals to 2 pi by omega. So this the a part of this question is the simple harmonic motion, and its time period is 2 pi by omega. Now moving forward to the B section of this question, and B section says that it is B says that it is sine cube omega t. Now we can use a trigonometric identity to transform this into linear form. So sine cube omega t can be written as 3 sine omega t minus sine 3 omega t divided by 4. Now here we again see that this is an addition of two periodic functions, but this can't be written in the form of either a cos omega t or a sin omega t. So this can't be simple harmonic motion, but indeed this is a periodic motion. So with the different frequencies here, in the first part we have omega t, and in the second part we have 3 omega t. So we can say that collectively it will repeat with the largest time period. So here the second part has a higher frequency. We can find out the frequency using this technique that we talked about earlier, that whatever is in the coefficient of t variable, we can equate it to omega, and that omega is equals to 2 pi by t. We can write t equals to 2 pi by omega. So using the same technique we can figure out the time period for this part, and that would be equal to, here the coefficient of variable t is 3 omega. So 3 omega will be equal to 2 pi by t. Now t would be, time period would be 2 pi by 3 omega. Similarly, time period for this part would be, omega would be equal to 2 pi by t. So t would be 2 pi by omega. Now we can see that this first part is 3 times that of the second part. So here the time period of the second part is much lower than the first part. So we can say that the addition of these two the time period for the collective function here is, it would be equal to 2 pi by omega, because this is the larger time period for which the function is repeating. Now moving forward towards the third part, so here this part says that it is indeed a periodic function with the time period of 2 pi by omega, but it is not a simple harmonic function. So the third part of the question says that it is 3 cos pi by 4 minus 2 omega t. Here in third part we can easily see that this can be closely related to a cos omega t plus minus 5. Now here we have to find out omega as well. So this is a simple harmonic motion indeed, and we have to, in order to find out the time period, we can relate the coefficient of time variable t with 2 pi by t. So let us go further. So in the C question we have 3 cos pi by 4 minus 2 omega t. Now in order to find out the time period, we need to take out the entire coefficient of time t. So it would be 2 omega would be equal to 2 pi by t, where t is the time period. So t would be equal to pi by omega. So the time period of this function would be pi by omega, and this is a simple harmonic function. So we can say that 3 cos pi by 4 minus 2 omega t represents a simple harmonic function, and its time period is pi by omega. Now moving forward towards the fourth question, we have cos omega t plus cos 3 omega t plus cos 5 omega t. So here again we see that this is an addition of 3 periodic functions. So indeed this is a periodic function, and the time period of this periodic function would be equal to the largest time period that this all would be having. So here omega would be equal to 2 pi by t, and here the omega would be equal to 3 omega would be equal to 2 pi by t, and in this part we have 5 omega would be equal to 2 pi by t. So here t would be equal to 2 pi by omega, and here t would be equal to 2 pi by omega, and here t would be equal to 2 pi by omega, 5 omega, here 3 omega would be equal to. Now we can see that when this part completes one cycle, the second part would complete 3 cycles, and the third part will complete 5 cycles. So collectively we can say that the time period for this collective function would be 2 pi by omega. Now this is not a simple harmonic motion, because this can't be represented in the form of a cos omega t or a sin omega t. Now in fifth part of the question, we see in the E part, we see that the function is exponent of minus omega squared t square. So this is an exponential function which is not repeating at any time. So this can't be either periodic or a simple harmonic equation. So this is none of those. Now moving forward to the last part of the question, F. It says 1 plus omega t plus omega squared t square. So this again is increasing function, which as t tends to infinity, it will tend to infinity and it will not repeat. So this can't be either periodic or simple harmonic function. Thank you. The question says that a particle is in linear simple harmonic motion between 2 points A and B, 10 cm apart. Take the direction from A to B as the positive direction and give the sign of velocity, acceleration and force on the particle when it is at the end A, at the end B, at the midpoint of A and B going towards A, at 2 cm away from B going towards A, at 3 cm away from A going towards B, and at 4 cm away from B going towards A. So this case can be illustrated using this diagram. A and B are the two extreme points, and here O is the midpoint of in which the SHM is being carried out. So here, as the particle moves from A to B, it is considered to be the positive direction, and when the particle moves from B to A, it is considered to be the negative direction. So in the first question we have at the end, when the particle is at the end of A. So when the particle is at the end of A, then the force is towards the mean position of the SHM or towards the B,